So for naming acids, it says that binary acid solutions form when gaseous compounds dissolve in water. An example would be when gaseous hydrogen chloride dissolves in water, it forms a solution called hydrochloric acid. So HCl, when it's in the gaseous state, and we denote that by putting a G in brackets, so that is hydrogen chloride. If I want to make hydrochloric acid, I take that gas and it's literally bubbled through water, and you end up with HCl that is aqueous. So aqueous just means it's a solution in water, and that would be hydrochloric acid. So there's a big difference between hydrogen chloride and hydrochloric acid. So how do we name these binary acids? Well, we use the prefix hydro, like hydrochloric acid. Then we add the anion non-metal root. So I have chlorine, so I use chlor in this case. So I have hydro and then chlor. And then I add ic and then acid at the end. So hydrochloric acid. Similarly, you could have hydrobromic acid. So if I have HBr, that would be hydrobromic acid. I could have hydroiodic acid. HF is hydrofluoric acid, very dangerous acid. Anyhow, for oxoacids, the names are similar to those of the oxoanions, except for two suffix changes. So if my oxanion or my oxyanion ends in ate, it becomes ic acid. So for example, if I had SO4 2-, so that is sulfate. So that would become sulfuric acid. So this, if I have H2SO4, that would be sulfuric acid. Then if I have the ite, so if I had, let's say, for example, sulfite, which is SO3 2-, then I would have H2SO3. Of course, you need two hydrogens to balance out these two negative charges. This would be sulfurous acid. Then a little bit more information about the hypo and per prefixes for oxo or oxyanions. These are retained. So for example, if I had BrO4-, so this is perbromate, it would be perbromic acid. So HBrO4 would be perbromic acid. And then IO2-, that's iodite. So HiO2 is iodous acid. And then if I had IO-, which is periodite, then if I had HiO, this would be periodous acid. So that would be periodous acid. All right, there we go. So let's take a look at a problem here. So sample problem 2.13 says, name the following anions and give the name and formula of the acid that would be derived from each of those. So if I look at Br, this is the bromide ion, so this is a bromide. And if I add a hydrogen to that, I can make the acid, so this would be HBr. So this would be hydrobromic acid. IO3- is iodate. So again, IO4- is periodate, and this is iodate. So we'll put iodate. And if I have a hydrogen added to that, I get HiO3, which would be iodic acid, because when it's ate, we end with ic acid. So this would be iodic acid. Iodic acid for an oxyanion. Then if I have Cn-, so if you remember the polyatomic ion Cn-, so this is cyanide, which I'm sure many of you have heard of cyanide before. So if I add a hydrogen to that, I get hydrocyanic acid. There we go. And then I have another oxyanion here. So this is hydrogen sulfate, so HSO4-, so this is hydrogen sulfate. So if I add a hydrogen to that, I would get H2SO4, and I get sulfuric acid. So there you go. So you should be able to name any of these acids by examining the anions.